exoskeleton is an option that we have. It can provide considerable strength to carry things. One of the disadvantages is cost. And the question is the maintenance. The question is who would be wearing the exoskeleton and on what missions.
While soldiers need strength and endurance on the battlefield, there are times when they also need stealth. Camouflaged uniforms can help soldiers move undetected when the mission calls for it. In the future, a revolutionary new technology might even make the soldier invisible.
If I were to make myself invisible to you, what I would do is I'd get a cloak. And the cloak would consist of a cylinder that I would put around me. What would happen is the light coming from the wall back there would hit the back of the cloak, come around, and then go right to you. So you would see basically right through me. With metamaterials and the new kinds of materials that we are developing, we are able to control light as never before. It's like a whole new ball game. You start with some sort of given material like silicon, let's say, or something like that, and then you embed it. You embed it with small nanoparticles or tiny gold rods or maybe even tiny slivers of semiconductors. Now, by making these metamaterials, we're able to control light in these new ways. All the textbook things you read about light are now wrong. We can do things that beyond all these limits.
So what we have here is actual experimental data of a working cloak. This works at microwave frequencies.
This region here is what you're cloaking?
So this region inside is the cloak, what would be cloaked, and this out here is the cloaking material. This is a truly invisible device. It's not just transparent like a piece of glass, where you can see that there's a piece of glass there because it distorts the scene behind it. This actually perfectly reconstructs everything.
The Duke Group did a very important experiment when they verified these ideas using microwaves, long waves. It proved that the concept of cloaking, the concept of metamaterials, the transformation that was used to make the light go around, it proved all those things were correct. But its limitation is that it was at one specific wavelength and not a visible wavelength. So there's 1,000 challenges in bringing that up to the visible. One of the most advanced concepts is the conformal cloak. And that's like a blanket. That's something that you could put around any object. Now the thing about a tank is it doesn't change shape too much. It moves and so forth, but there you know the shape, and then you could design a conformal cloak that fits right on the metal and render it invisible. Anything that fits around a person or an object, so a shirt, it could be the uniform, or it could be a blanket they put around themselves. I think the applications are widespread. It's just that we're not ready to build things like that yet. They're just years off. It's going to be a while before soldiers have cloaking devices, but that's the ultimate goal.
Imagine if we took, all the small arms projectiles that the Army uses now, and we hand one small arm projectile to the soldier, okay, with one weapon system. Just imagine what that would do for the Army if we could do that.
And imagine a projectile 10 to 20 times more powerful than anything used by today's soldier. To get that bigger bang, Army researchers are trying to develop a new kind of explosive, using what they call disruptive energetic materials.
Currently, we're exploring materials that you normally would not consider to be explosives, such as nitrogen or hydrogen or carbon monoxide. These are materials that we're planning on putting in the Army capabilities within 15 to 20 years, so far-term research.
They're testing the use of lasers as a possible way to trigger the awesome explosive potential of these exotic materials.
We're also working on materials that have what we call dial yield performance. That is, the soldier himself could decide what type of performance level he wants out on the field, where you could have one explosive doing the job that we have several explosives doing right now.
The soldier would be able to control that effect in the future. You could potentially use that round against an armored vehicle to destroy it. take it to the far extreme, we could also have non-lethal capability into that round by just understanding and controlling those materials. This is a whole new class of materials that if we do it correctly, it's a game changer.
So one of our other challenges is being able to hit the target every time. That's our future vision. Every time the soldier pulls the trigger, he hits the target. So our focus is developing the technologies that will allow those precision-guided munitions to be produced at a very affordable cost. For the shoulder launch systems, we're looking at literally shrinking the capability that you would get out of a tank or an artillery round today into something that a soldier could launch from his shoulder. Another huge challenge for us is engaging targets in urban environments between buildings. So a system like this would allow him to shape that trajectory to fly up and over and actually come back into the reverse side and then tailor the effect, the warhead effect itself.
Full spectrum capability in the hands of the individual soldier, tank-like lethality. So one round that would replace many, many rounds is where we see the future of lethality going.
Soldiers of the future will also be more connected, sharing vital information with their unit and other sources, using powerful electronic tools to get the right data at the right time.
You have to limit the information to what the soldier needs to function. Situational awareness will be coming to him from sensors. He has to have his own sensors.
Just getting into a good position, over.
We've got to make sure not only soldiers can talk to each other by voice comms and by messaging. On top of that, you've got to communicate with all the different sensors on the battlefield. This includes everything from the unmanned aerial vehicle to unmanned ground vehicle, so something you might kick out into a building before you enter. If you're carrying something like the any kind of ground soldier system, hopefully we can get that down to a smartphone. Like when you want soldiers A and B to go to place C, like, you know, just go up to them and grab them and shove them over there. Well, that's the team leader's technique, right? When a platoon leader wants somebody to go somewhere, he can drive what's called a chem light on the screen. That tells them instantly where to go. So when a platoon leader wants two squads to maneuver, you know, kind of around building X and the other one to come up to the front of building X. So with the screen, hopefully, it'll just be able to say, you here, you there.
You give him the information that he needs in terms of where he has to go, who is with him, how, you know, what you should look out for on this road, what's the experience. You would be able to sense infrared, sense invisible, have a receiver for your radar. You could put the optic, slide the optic off of your helmet, and the optic would tell you there is an unknown at 800 meters to your front, moving from left to right. So he could see the target, he could gain instant advantage in terms of situational awareness. He's got all the information he needs in a very compact form, either on his wrist, on an optic that comes across his face. Those are the kinds of things that would make his job much easier.
For the most part, our target audience, it really is the individual soldier. That typically is, again, looking at developing the beginning stages of technology that is, for the most part, going to be used by the soldier on the ground. You can have applications that enable you to plan new routes in a more efficient manner. Ways in which you can display information coming from a forward operating base in a more efficient fashion. Or custom tailoring displays and custom tailoring technologies to the individual roles within a squad. So instead of everybody getting everything, then you have the right information in the hands of the right people at the right time. And all of that kind of builds together to make the soldier more efficient. As a result, we're looking at the brain and the body in the context of the mission. So we are really concerned with the soldier and their environment.
And researchers are exploring the use of sensors to tap a soldier's brain power as a way to monitor and even improve their performance.
These systems, by their nature, have to be located on the head, which means they have to be located under a helmet. When a soldier is subject to a blast or is subject to a ballistic event, a bullet that hits them in the head, Well, those pieces of metal that would be inside of the helmet then become secondary projectiles. So any type of design that is dependent upon metallic sensors probably not going to be able to be deployed in helmet, in battlefield types of situations. So some of the things that we've been working on are foam-based sensors, so sensors that use conductive fabrics and conductive foams that can actually be part of the protective element of the system, and then they could actually be integrated with the foam padding of the helmet. It's critical for us to get the best sort of measurements that we can. So some of the sensor work that we're doing right now is really aimed at getting those measurement capabilities to a point where we can actually really use them in the real world as our soldiers are moving through urban operations, moving through across cross-country terrain. And sometimes we can pull off signals from the brain that are that signify when when a person has, for example, identified a target and may not even be conscious that they have.
The future soldier might even have the ability to control a computer device through a direct link to the brain, hands-free.
One of the more straightforward applications that we can think of is how can we utilize brain signals to actually directly control our interactions with a computing system. The approach of brain-computer interaction technologies is to design systems that function naturally with the way in which soldiers' brains function, to effectively perceive and process information. When you actually do these types of brain-computer interaction interfaces, trying to take away the burden of manual interaction with the computer system, well, it's actually quite effortful. So some of the things that we can do in the laboratory, obviously, they take some time.
Army researchers are also focusing on new ways to keep the future soldiers' high-tech gear powered up and ready.
You think about the soldier, people are thinking about the soldier, what power requirements he has. You think about there's computing, there's communications, there's displays, and I think all those arenas there's potential for reduced energy demand. We're trying to get to a 5-volt battery. That would potentially extend the capability of the battery by roughly 30%. Translate to soldier, roughly 1/3 less batteries you'd have to carry, or 3 times mission duration for the same battery.
A lot of our stuff right now on a sort of standard soldier gets powered by its own battery, but not all of it, not like all of the communications, for example. How do we go ahead and try to integrate all of those power sources, maybe into one common power source, or do some kind of breakout of some powered by each individual battery and some powered by a central power source? And what are the problems if we think even bigger than that and say, how do we power a mission? And how do we get a small combat unit or a tactical small unit? How do you distribute power among that squad? And how do you distribute parts of a power generator or something among that squad? You're losing some individual capability.
The Army is putting together a doctrine called operational energy. And part of the doctrine says, hey, I want to be able to use energy more efficiently, reduce reliance on fuel and recharging and battery resupply. So I want to be able to produce and use energy locally wherever possible. So, this is where some of the alternatives come in. And then we're looking at some alternatives besides batteries. We're working here on fuel cells and some fuel cells that may be able to use a variety of different fuels.
Even more sort of further out there might be developing wireless technology so that within a radius of whatever number of miles we need, everything in that radius will be powered without you having to do anything or carry anything.
One of the things we realize is that the soldier is not a person who can carry any weight you want to put on his back. A person has limits in terms of his endurance.
Our job is to really increase the capabilities for the soldier, but reduce the weight at the same time.
From the science and technology point of view, it's a total ground-up development effort at headgear design. Lighter, stronger, more integrated. We want a streamlined solution that commanders can up armor or de-armor their soldiers depending on the mission. Lightweight materials that are not going to induce near or short-term injuries to the neck and back. lighter materials for improved mission performance, and just the overall streamlined system. We're looking at the balance and the center of gravity of the helmet from the biomechanical point of view, and then to go along with that, we're taking a look at the weight of the helmet, obviously, to reduce soldiers' load. We're investigating some new heads-up display technologies, more particularly see-through heads-up display. You have that micro display, it's a solid piece of equipment, and it reduces your field of view. So we're looking at technologies that will help open up that field of view and give the soldier more peripheral vision. Soldiers are experiencing